Hello everyone, this is for Honors Pre-Calc. This is Integration Lesson 3. We're going to talk about the mean value theorem and the second fundamental theorem of calculus. Also, we're going to try and throw in some area between curves to help you guys out with some other things. Now, we have talked about the fact that a definite integral from a to b of f of x dx, that equals the area under a curve. So if I were integrating from a over here to b over here, the area under that curve can be found by this integral. Now, what the mean value theorem is saying is that that area should equal the area of some rectangle. If you take the length of this interval, b minus a, how do you find the length between any two numbers? You take the bigger minus the smaller. That's b minus a. And there is a certain height somewhere on this function here, some f of c, some c value on this interval, where the height of this rectangle times the base of this rectangle, the area of this rectangle, would actually equal the area under the curve. And see this value f of c right here. This value f of c is actually called the average value of the function. So if you took all infinitely many y values along this function, that's the average of all of them. Now, how do I find average value? The average value is found by, well, let's just divide by b minus a to the other side. 1 over b minus a times the integral from a to b of f of x dx. That is going to give me the average value of my function on that particular interval. Now, we're going to take a look at quite a few examples here to show how this works. Okay? So if I said find the average value of a function, 3x squared minus 2x, and I said I wanted you to integrate that from 1 to 4, find the average value from 1 to 4. So if you look at this function, I actually graphed it on my graphing calculator and pasted it into this set of notes. This is the graph of 3x squared minus 2x, okay? And this is actually graphed from 1 to 4, okay? Now, we are saying there is some height right here times this width, where the area of that red triangle I've drawn, and I hope you can see that in my picture here, where the area of that rectangle actually equals the area under the curve, okay? How do I find that? I set up the integral of 1 over b minus a times the integral from a to b of f of x dx. Now, what's a and b? This is a, this is b. So I got to do the integral of 1 over 4 minus 1, which is 3. The integral from 1 to 4 of 3x squared minus 2x dx. Okay? Now, what I always tell my calculus classes, and you guys are going to see this next year as well, I have to see that antiderivative. This is 1 over 3, do a power rule, add 1 to the exponent, divide by the exponent, I would get x cubed. Add 1 to the exponent, which would be 2, divide by the 2, you'll get minus x squared. Now, this step right here is the first fundamental theorem, which we talked about in the previous lesson. You plug in the 4 first, minus, you plug in the 1 second, and then you evaluate. I get x equals 16. I get the integral equals 16. Now, that, ladies and gentlemen, is f of c from this theorem in this average value definition up here. F of c equals 16. That is the average value of f of x. Okay? Now, some problems may ask, well, where does that average value occur? In other words, what x value is giving me that height? Well, that's easy. It says, right in the formula, it says f of c equals 16. Well, what's f of c? My original function was 3x squared minus 2x. Just set that equal to the 16 and solve. We're going to subtract the 16. Now, this actually factors, but you could use a quadratic formula. You could use a graphing calculator. This factors into 3x minus 8 and x plus 2. That, if I solve it, add the 8, divide by 3, I'd get 8/3. This one, if I set it equal to 0, I'd get negative 2. But wait a minute. X equals negative 2 is not on that original interval, so I'm not going to use x equals negative 2. At 8/3, if you integrate, or if you graph this function from 1 to 4, at 8/3, about right there, the average value occurs. So if I plug 8/3 into this function, I would get 16. Okay? And that is the average value. Now let's take a look at the next page and some practice problems. Again, if at any time any of this isn't making sense, you can pause the video, you can text me or email me and let me know what kind of problems you're having. Okay? Now this next problem says find the average value of this function on this interval. And again, it's very simple. If you keep the formula in front of you, it's 1 over b minus a, b minus a, the integral from a to b of my function dx. And if I'm giving you a test next year, that's the first thing I would need to see is that setup. Be able to set up the integral. Now the next step is to take the antiderivative. Well, there's the 1/3 out front. Power rules all across the board. Add 1 to the exponent, becomes 4. Divide by the new exponent. Add 1 to the exponent, it becomes 2. Divide by the exponent. 4. It's like 4x to the 0. The antiderivative of a constant is the constant times x. Plug in the 4. Plug in the 1. And subtract those results. And this is calculator work. You guys obviously have calculators at home, so you can just punch that in. I get 71 over 4. Okay? Now, if I wanted to figure out where that average value occurred, this is the average value. At what value of x does that occur? I could set this function equal to 71 over 4. Okay? And then all I'd have to do is set this equal to 0 and graph it on my graphing calculator and look for the x-intercepts. Now remember, you'd only want to look for the x-intercepts on the interval from 1 to 4. So that's how you could figure out where the average value occurs. At what x value does the average value occur? Another average value problem here. Okay, what's the average value of 4 radical x from 4 to 9? Well, a, b. The integral is multiplied by 1 over b minus a from a to b of f of x dx. It's a simple setup. If you understood the last lesson, the rest of this is going to make sense. Add 1 to the exponent. 1/2 plus 1 is 3/2. Multiply by 2/3 out front. There's my antiderivative. Where'd that 1/5 come from? It's my fraction out front. Plug in the 9. How do I get 27? The square root of 9 is 3. 3 cubed is 27. And 8 over 3 times 1/5 is the 8/15. Plug in 4. Square root of 4 is 2. 2 cubed is 8. Then I just punch it in my calculator. And I insist next year that I see this step where they've plugged in the numbers. So if you're taking this on a test for me next year in calculus, I would demand to see the integral. I'd have to see the antiderivative. I'd have to see how you plugged in the numbers in the final answer. That's my expectations if you're doing this type of question on a test or a quiz next year. Now, somehow my problem got screwed up here. This should not be in there. This should just say 3 e to the x. What is the average value of 3 e to the x on the integral from 1 to 5? Okay. Set up my formula. It's 1 over b minus a, the integral from a to b of f of x dx. Now, what is the antiderivative of e to the x? It's e to the x. So 3 times e to the x, the antiderivative is 3 times e to the x. There's my 1/4 up front. 1/4 times 3 is 3/4, so I plugged in the 5. I plugged in the 1. There's my final answer. Excuse me. Okay, and I hope all this is making sense. If it isn't, maybe you'll have your formula sheet in front of you. Okay? What is the average value of this function? X squared minus 4 over x from 2 to e. All right? So it's 1 over e minus 2, b minus a. The integral from 2 to e of x squared minus 4 over x dx. Now, we really can't simplify that 1 over e minus 2, but this is a power rule. Add 1 to the exponent, divide by the exponent. Now, what's this? Look at your formula sheet. 1 over x, the antiderivative, is the natural log of the absolute value of x. So 4 over x, the antiderivative is 4 times the natural log of the absolute value of x. Now, how do I work this out? This is my antiderivative right here. Plug in the e first. Plug in e, plug in e. Take that result and subtract, plug in 2, Plug in 2. Now, this whole thing is over e minus 2, but this is 1/3 e cubed right there. That's minus 4. And then this would be minus 8/3. So negative 4 minus 8/3 is negative 20/3, and there's the 4 natural log of 2. Now, what did I do to get from this step to this one? I have a common denominator of 3, so I multiplied that entire top by 3, and I multiplied that entire bottom by 3. Those 3's would cancel, give me e cubed. Those 3's would cancel, give me minus 20. And 3 times 4 is the 12 natural log of 2. Now multiply the 3 across the bottom, I get 3e minus 6. Hope this is making sense, everyone. Okay? And that's how we find average values of functions. Now, this is a little bit different topic. You know that the integral, we talked about this throughout this lesson, we talked about this in the previous lesson. What does the integral from a to b of f of x dx mean? It means take f of x and find the area below it, between that and the x-axis. So what's the integral from a to b of g of x? Well, it's the area under the curve of g of x between that and the x-axis. Well, what if I took that area and I subtracted off that area? It would give me the area between the curves. So how do you find the area between curves? You take the top curve and you subtract the bottom curve when you're integrating with respect to x. And you can find the area between two curves. So I'm hoping that it's obvious in this problem at the bottom of the page here. Okay. When I say obvious, the x squared plus 3 is the parabola right here. The negative x plus 1, start at 1, down 1, right 1, down 1, right 1. There are my two functions. How do you find the area in between those two functions? And it says do it from x equals 0. This is x equals 0. This is x equals 2. Take the top curve minus the bottom curve and integrate on that interval from 0 to 2. Okay. Now, by the time we get to this in calculus next year, we'll have done a lot of integration. So we'll know, combine all the like terms here. 3 minus 1 is the 2. Negative minus x, positive x. This is my antiderivative. Add 1 to the exponent. Divide by the exponent. Add 1 to the exponent. Divide by the exponent. The antiderivative of a constant is the constant times x. Plug in the 2. And if you plug in 0, you're going to get 0 plus 0 plus 0, so that's just going to give me 0. And calculator work for you guys from there. It's 26/3. The area between those two curves is 26/3. Okay? Now, as I move along here, you guys are going to see I'm going to mix some things up a little bit. Not much. Find the area between these two curves. Now, what I did this time was I did not include the boundaries. Here are the boundaries right there and right there. I am going to take the top curve minus the bottom curve, and I'm going to integrate. But how did I figure out that this was -4? Well, it certainly looks like it's -4, but how could I be sure? It certainly looks like 1, but how could I be sure? How do I find the intersection of two different functions? Well, I set them equal to each other. Okay? Subtract that x. Actually, let's add the 2x over here. Let's subtract the 5, and let's add the x squared. So I have a positive x squared plus 3x minus 4 equal to 0. Why do I want to set it equal to 0? This is a quadratic. I can factor it into x plus 4x minus 1. Set that equal to 0, I get -4. Set this equal to 0, I get 1. Those are my two boundaries for my integral. So again, combine like terms here. Top curve minus bottom. Quadratic minus linear. It's negative x squared, negative 2x minus x, negative 3x, 5 minus 1, positive 4. Antiderivatives. Add 1 to the exponent, divide by the exponent. Add 1 to the exponent, divide by the exponent. The antiderivative of a constant, constant times x. Which number do I plug in first? Always the top number first. Plug in the 1, minus. plug in the bottom number, -4. And again, use your calculator here. The biggest issue is going to be negatives. Watch your negatives. Watch your parentheses. You should come out with 125/6. Okay? That didn't seem too bad. Okay. What about this problem, though? I have a cubic here that goes up, comes back down through the origin, goes back up. That's f of x. This quadratic that goes through here hits 0 and then hits a 2. Well, that's g of x. Now, how do I find the area between those two curves? Well, I'm just going to tell you so we don't have to go through the whole solving process. This does intersect at -2. This does it. They do intersect at 0, and I think it's pretty obvious those intersect there at 2. Now, here's the problem. I told you previously that you got to take the top curve minus the bottom curve. But here the top curve is the cubic. So on this section right here that I've colored in black, okay, I have to take f of x minus g of x. F of x minus g of x. And I have to integrate that from that intersection point at -2 until I get to 0. Now when I get to this red section here, the cubic is no longer on the top. The quadratic is on the top. So I have to take g of x, the quadratic, minus f of x, the cubic, when I go from 0 to 2. Now, I've tried to color code that up here so you can see what I've done. This is the area of the first piece from -2 to 0, f of x minus g of x. When I go from 0 to 2, I have to take g of x minus f of x. And that is a pain in the butt to write out, but here's the great thing about this. When I subtract here, I get 3x cubed minus 12x. When I subtract the other way, I should just get the opposite, -3x cubed plus 12x. Their antiderivatives are going to be identical, except for signs. Add 1 to the exponent, divide by the exponent. Add 1 to the exponent, divide by 2. And over here, it's just going to be the opposite. When you're doing this one, you have to plug in 0, which is going to give me 0, minus. You're going to plug in -2. Addition. This one here, you have to plug in the 2 first. Plug in 2, plug in 2. Minus, then you have to plug in the 0. So antiderivative at 0 minus antiderivative at -2, plus in the middle. Antiderivative at 2 minus antiderivative at 0. And again, when you're doing these assignments, obviously you're going to use your calculator. Just punch it in, you get 24. Now, would this be easy to do on your calculators? We discussed this in the last lesson. Yes, you could punch this into your calculator. That'd be something that would be easy to do. Okay? In fact, it's something I can show you. If I want to plug this in, I'm going to make my life a little simpler. Okay? Now, I hope all of you can see my calculator. I'm going to zoom in on that calculator screen. Okay? I'm going to keep most of the problem covered up because here's what I'm going to do. I'm going to go to y equals. I'm going to put f of x. Okay? F of x is 3x cubed. Okay? It's minus x squared. And it's minus 10x. That's y1. G of x is negative x squared plus 2x. Now watch what I can do here. Let's say I want to get this problem done very quickly. I wouldn't recommend doing this every time. If you get stuck, I'd recommend this. Math, number 9. There's my integral. Obviously, my first integral is -2 to 0. And what did we say we had to do? We have to take f of x minus g of x. So what I can do, f of x is under y1. You can hit the alpha key in the green here. Let me move this up a little bit. Hit the alpha key in the green. Okay. When you hit that alpha key in the green, sorry about my glare, you can go to the trace button. And look at that. Number 1 is y sub 1 minus, do it again, green key in the trace button. Number 2 is y sub 2. Ladies and gentlemen, I just punched in f of x minus g of x. And then I can add, do it again, math number 9. Again, that's math number 9. Goes 0 to 2. This time I need to take g of x minus f of x. So alpha trace, g of x is y sub 2 minus alpha trace. I got to put in f of x next and then with respect to x. Oh, and by the way, I want math number 1 because I want to see if this will give me a fraction. There we go. That's what I got. Look at this. On my paper right here, it says 24. Okay? Calculator can do a lot of things. I hope that makes sense. Now, so you notice there I had two different areas. I had to switch which function was on the top. Okay? This problem right here, what's really cool about this problem is I think when you look at this problem on paper, it kind of looks like that integral or that area is the same as that one. Okay? Now, it does say find total area. It doesn't say to evaluate an integral. So when it says area, I need a positive answer. If these two areas look the same, couldn't I just find this one that I've shaded here and then double it? This integrates from 0 to 4. The function is x radical 16 minus x squared with respect to x, and I have to double that. Okay? Now, what I'm giving you a preview of here is something we're going to do in the next lesson. It's called U substitution. I have no idea what the formula is for this. So what I'm going to do, okay, I notice this is a composite. How do I integrate radical something? I don't know. So let's let U equal what's under the radical. So instead of this being 16 minus x squared to the 1/2, it's just going to be U to the 1/2. Okay? Now here's what I'm going to do. You see the dx? That means I'm going to have to take some derivatives. Take the differential of U. That's du. What's the derivative over here? It's negative 2x dx. Now another way to think about that is if I take the derivative of U with respect to x, it's absolutely negative 2x. Multiplied by the dx. That's where I got this equation. Now look at my problem. Everybody see the 2x dx in the problem? Divide by that negative. The 2x dx in the blue, what's underlined in the blue becomes negative du. This is called U substitution. We're going to do a little bit more of this in the next lesson. Now, plug in 0. This is x equals 0. If you plug in x equals 0, you get 16. If you plug in x equals 4, you get U equals 0. So what we've done here is we've taken everything in terms of x and switched it to values of U. By the way, I hate having that negative out there. I hate having this going 16 to 0. It should go 0 to 16. Remember the properties we talked about in the previous lessons. You can switch those limits of integration and negate the integral. So if I switch this to 0 to 16, it becomes a positive. Now take the antiderivative. Add 1 to your exponent. Multiply by the reciprocal. Multiply by the reciprocal. Plug in the top number first, bottom number second. I get 128 over 3. Okay? One more question to round out this lesson here. And I'm not going to totally finish this problem because you could punch it in your calculators, but you'll notice in this one, on this piece, the line is on the top. On this piece, the line is on the bottom, and on this piece, the line is back on top. So for this red piece right here, from negative 2 to 1, I'd have to take the blue line minus the red curve. 2 minus x minus 4 minus x squared. But then when I go from negative 1 to 2, I'd have to take the red curve, which is the quadratic, minus the linear problem, which is the 2 minus x. And then this piece in the blue down here, it runs from 2 to 3. 2 to 3. I'd have to take the line minus the quadratic again. So watch out for area between curves. You got to make sure that you take top minus bottom when it's in terms of x. You'll see next year we even do some things in terms of y. Again, if you have any questions about this, make sure you text me or email me or set up a Google chat if you'd like. This will get you through integration number 3 on the Math Excel. Hope you're all doing well, staying safe and healthy. Herm Dog out.